What if everything you think you know about the universe is wrong? What if every law of physics, every galaxy, every single atom, and even the very concept of time itself was secretly shaped by a colossal secret? What if we are living inside a giant black hole? It sounds like science fiction, right? But brand new data from the James Webb Space Telescope is forcing scientists to ask this very question. The telescope recently looked deep into the cosmic past and found something that shouldn't be there. It saw that 2/3 of distant spiral galaxies are all spinning the same way clockwise. In a random universe, that's like flipping a coin 1,000 times and getting heads 660 times. It's a pattern so strange. Some theorists argue it could only happen if our entire universe inherited its spin from a parent black hole. And it's not just the spin. The geometry matches too. The boundary of our observable universe, the farthest we can possibly see, is the exact size you'd predict for a black hole's event horizon, given the total mass of our cosmos. If this mind-bending theory is right, then everything, from the Big Bang to the direction galaxies spin, could be the echo of a much larger, much older gravitational engine. But how could we possibly know for sure? To answer that, we need to rethink what a black hole really is. A black hole isn't just a hungry monster in space. It's a region where gravity is so incredibly intense that nothing, not even light, can escape. There's a boundary around it called the event horizon. Cross that line and you're gone for good. But here's the twist we never consider. What happens on the asterisk inside asterisk? According to Einstein's theory of general relativity, once you're inside, space and time get scrambled. All paths through space-time curve inward, pulling everything toward a single point at the very center, the singularity. This is a point where density and gravity become infinite, and the laws of physics as we know them completely break down. Now let's flip the script. Instead of imagining falling asterisk into asterisk, a black hole, imagine you were born asterisk inside asterisk one and are now looking out. That event horizon isn't a wall. It's more like a one-way mirror. From the inside, you could see everything within your cosmic bubble, but absolutely nothing from the world beyond. That would be your entire universe, sealed off by a boundary you can never, ever cross. This is where things get really strange. The boundary of our visible universe, the farthest distance light could have traveled to reach us, since the Big Bang acts a lot like an event horizon. It's the edge of everything we can know. Any information beyond it is forever out of our reach. And when you take the math that describes a black hole as event horizon and plug in the estimated mass of our universe, you get a boundary that is eerily close to the size of the cosmic horizon that astronomers measure today. It's not a perfect match, but it's so close it's making physicists raise their eyebrows. So, what would it actually mean if our universe is the inside of a black hole? Well, for starters, the singularity, that point of infinite density, could be reimagined as the Big Bang itself. The moment when all of space, time, and energy burst outward from an unbelievably dense state. The event horizon would become the absolute limit of what we can ever observe. Everything we see, from the oldest galaxies to the faint afterglow of the Big Bang, is trapped inside this cosmic bubble with us. And outside? That's not just empty space. It's a region we can never touch, never see, and never know. Physicists have debated for years whether these similarities are just a wild mathematical coincidence or a clue to something much deeper. Some have even proposed that our universe's beginning wasn't a singularity at all, but a white hole, the time-reversed twin of a black hole, blasting matter outward instead of sucking it in. Others point out that if our universe did inherit its spin from a parent black hole, we should expect to see traces of that rotation imprinted on the largest structures we can observe, just like the JWST may have found. The stakes here couldn't be higher. If this is true, then everything we thought we knew about beginnings and boundaries has to be completely rewritten. To understand how this could even be possible, we need to go back to 1915 and Albert Einstein's theory of general relativity. It gives us the rules for how gravity shapes space and time, and it's the very physics that allows black holes to exist. The equations are unforgiving. If you pack enough mass into a small enough space, gravity always wins. Space curves in on itself, and you get a black hole. No escape, but the math reveals there's more than one kind of black hole. The simplest is a non-spinning one with a single point singularity. But the more realistic kind, the one that actually forms in nature, is called a Kerr black hole. It spins. Instead of a point, its singularity is a ring. The space around it gets twisted and dragged, pulling everything along for the ride. Now here's where it gets wild. General relativity has a fascinating symmetry between collapse and expansion. If you flip the direction of time in the equations, a black hole becomes a white hole, a region that explodes matter out, which is impossible to enter from the outside. Some physicists believe the Big Bang was actually the inside of a white hole, a rebound from a collapsing parent universe. In an spinning black hole, this rebound could happen through the ring singularity, launching a brand new expanding region of spacetime, our universe. And what about the boundaries? A black hole has its event horizon. Our universe has a cosmic horizon. As we said, if you plug the universe's estimated mass about 10 to the power of 46 times, the mass of the Sun into the black hole equation, you get a radius of around 14 billion light-years. That's astonishingly close to the size of our observable universe. The spinning Kerr black hole adds the final crucial piece. Because it spins, it can pass on its angular momentum. If our universe was born from such a parent, you'd expect to see traces of that original rotation left behind, perhaps in the large-scale patterns of how galaxies spin. The properties of the parent black hole, its mass, its spin would set the initial conditions for everything inside. This isn't fantasy. General relativity provides the foundation for this mind-bending possibility. This brings us back to the James Webb Space Telescope. Astronomers using the JWST survey set out to answer a simple question. Do early galaxies spin randomly, or is there a hidden pattern? They captured high-resolution images of 263 distant spiral galaxies, some of the oldest we've ever seen. To figure out which way each galaxy was turning, they used an algorithm called Ganalyzer. This software simply traces the winding arms of each spiral and assigns a direction, clockwise or counterclockwise. The results were a shock. Out of 263 galaxies, roughly 66% appeared to be rotating clockwise from our vantage point. Only a third spun the other way. If standard cosmology is correct, the universe should be the same in all directions. Galaxy spins should be like coin flips 50-50. Instead, the JWST data showed a clear, undeniable imbalance. This kind of asymmetry is exactly what you might expect to find in a universe born from a spinning parent. The computer scientist behind this analysis, Lior Shamir, has been searching for these patterns for years. His earlier work hinted at this, but it was always debated. Now, with the power of the JWST, the evidence is stronger than ever. Of course, this is still just one study. More data is needed. But it's a tantalizing clue that our cosmic home might be far stranger and far more connected to the mysteries of black holes than we ever dared to imagine. So, are we living inside a black hole? The question is no longer just for science fiction. It's now at the cutting edge of cosmology. Have you ever wondered what came before the Big Bang? For decades, it's been the ultimate question, a point where physics breaks down. But what if the Big Bang wasn't a beginning, but a bounce? A rebound from a collapse happening in another universe, far beyond our sight. This wild idea has been kicking around the edges of cosmology for years, but new data from the James Webb Space Telescope has just thrown it back into the spotlight. A team of astronomers was looking at distant galaxies, the kind of ancient spirals that were forming when the universe was young. They weren't looking for anything grand, just classifying shapes and structures. But they stumbled upon something bizarre. In their sample of 263 spiral galaxies, far more seemed to be spinning in one direction clockwise than counterclockwise. We're talking about a 66% majority. That shouldn't happen. The universe on the grandest scales is supposed to be the same in every direction. There shouldn't be a preferred spin. The team was baffled. They checked everything. They mirrored the images, flipped the coordinate axes, and even randomized the data to see if their software was biased. But the result wouldn't go away. This excess of clockwise spirals stubbornly persisted. It's a finding so strange it hints at something truly fundamental about the cosmos. It suggests the universe itself might have a built-in handedness, a memory of a cosmic scale rotation right from its earliest moments. Of course, extraordinary claims demand extraordinary evidence. 263 galaxies is a tiny sample in a universe of billions. It's just one small patch of sky. Past surveys that have hinted at similar patterns have fizzled out, revealed to be simple flukes or quirks in the telescope's hardware or the analysis software. But if this pattern holds up as we gather more data, the implications are staggering. It could be the first real clue that our universe was born from a very specific and very strange kind of object. To understand how this could happen, we need to dive into the weird world of rotating black holes. When most people think of a black hole, they picture a singularity, a single point of infinite density where everything ends. But that's only for a non-spinning black hole. The universe is full of rotation, and when a black hole spins, the rules get bizarre. The physicist Kerr figured this out mathematically way back in 1963. He showed that a rotating black hole doesn't have a point singularity. Instead, it has a ring singularity, a one-dimensional loop where gravity goes haywire. And here's the mind-bending part. This ring might not be an endpoint. The math suggests it could be a gateway. If you could somehow pass through this spinning ring, you might not be crushed, but instead emerge into a new region of spacetime. Some models describe this as the black hole turning into a white hole, a cosmic fountain spewing matter and energy outwards, forming a brand new universe. The spin is crucial. As the black hole rotates, it drags spacetime around with it in an effect called frame dragging. Near the ring, this twisting becomes so intense that it could provide the outward push, the bounce that ignites a new Big Bang. If our universe was born this way, from the heart of a spinning black hole in a parent universe, it would inherit some of its parents' traits. The most important one? Angular momentum, spin. A newborn universe created from a spinning black hole should itself be spinning on a cosmic scale. And that primordial rotation could leave a fingerprint on the cosmos we see today, seeding a preferred direction in the way galaxies form and spin. This is the testable prediction. The standard model of cosmology, with its period of rapid inflation, says any initial spin should have been wiped out in the first moments of existence, leaving the universe perfectly uniform. But if the JWST's strange signal is real, it might just be the cosmic memory we've been looking for. This idea leads to an even grander vision, championed by physicist Lee Smolin, called cosmic natural selection. What if every black hole in our universe is a seed for a new universe? In this model, black holes aren't cosmic graveyards. They're cosmic cradles. Each time a massive star collapses, it doesn't just create a black hole in our universe. It sparks the Big Bang of a new hidden universe. Each new universe inherits slightly tweaked physical laws from its parent. Universes with laws that are good at making black holes will have more offspring. Over countless generations, the multiverse would naturally become populated by universes like ours, ones perfectly tuned to create stars, which then collapse into black holes, continuing the cycle. In this incredible picture, the finely tuned constants of nature that make our existence possible aren't a lucky accident. They are the result of an evolutionary process on a cosmic scale. Our universe isn't a one-off miracle. It's a successful branch on an infinite cosmic family tree. Black holes aren't the end of the story. They're the engine of creation itself. But let's pump the brakes. Skepticism is the engine of science, and to claim this big needs an airtight case. The JWST's finding is fascinating, but it's just a hint. The history of astronomy is filled with tantalizing patterns that disappeared with more data. Was there a subtle bias in how the galaxies were selected? A quirk in the telescope's instruments? A blind spot in the classification algorithm? These are the tough questions scientists are asking right now. The original team did their best to rule these out, but the final verdict is still to come. Thankfully, we won't have to wait long. Help is on the way from two massive new projects. The Vera Rubin Observatory in Chile is about to begin a decade-long survey that will map billions of galaxies. Its data will be completely open source, allowing anyone to check for bias. Meanwhile, the European Space Agency's Euclid mission is already in orbit, creating its own vast map of the cosmos. Scientists on that project are running double-blind studies on galaxy spin to avoid any subconscious bias. If the galaxy spin asymmetry is real, it will show up in these massive datasets, not just in one small patch of sky. If it doesn't, it will join the long list of brilliant ideas that didn't quite match reality. So where does that leave us? We're standing at a fascinating crossroads. For now, the standard model of the universe, with its simple, non-spinning beginning, remains the champion. But for the first time, we have a small but stubborn piece of evidence that points to something else, something wilder. A universe born from the spinning heart of a black hole, a universe with a cosmic spin it inherited from its parent. The next few years of data will be decisive. Is this a statistical fluke, a ghost in the machine? Or is it the first glimpse of a new cosmology, one that connects our universe to a vast, unseen multiverse? The answer is out there, written in the spin of the galaxies. We just have to keep looking. Thanks for joining us on this journey to the edge of what we know. If you enjoyed this dive into cosmic mysteries, be sure to like this video and subscribe for more adventures in science. We'll see you next time.